Hi, and welcome to the WebRTC monthly Fiddle. This time we're going to talk about checking the audio levels. Now, I guess the first thing to ask is why would we want to do that and what exactly we're talking about. So we are in a call, okay, and we're speaking. Now I want to understand what is the audio level that we're either sending or receiving in the call. Now we're not going to talk in this Fiddle on the sender part. We'll leave that to you to do, probably with web audio. What we want to discuss and deal with is what you do with the incoming channels. Okay, for an SFU, media gets routed. We can have 1, 2, 3, 4, 10, 20 different audio streams coming in, and we would like to understand, who is the one that is speaking, or who has a dog barking in the background where you don't have the new noise suppression machine learning stuff in the application that you are using. Okay, so there are three ways to do that. Okay, the first one is, well, we can use web audio. If we use web audio, we actually need to use CPU processing to understand the audio levels, get them, and then deduce from that what to do. The second approach that we have is getStats. And we like getStats and use it all the time. In this case, well, we're going to go try to dig into getStats to the audio levels that we need, collect that, do things with it. That's nice, but Flipper wants to do it at an interval of every 20 milliseconds, which means too many calls to getStats. Okay. Now the third approach is to use getSynchronization_sources, which is quite straightforward. And what I'll do now for the actual explanation of how you do that is hand it over to Flippo.
Thank you. So let's talk about the fiddle. We have a bit larger fiddle this time, and it's basically split in two parts, or three parts. First part is initialization of some things, and then negotiating a active peer connection, because we're going to look at the remote audio level. So we need a active peer connection. And we do the usual thing. We get a stream from getUserMedia. Over here, then we call add track for each of the tracks in the stream, which is just a single track, but we iterate over all the tracks anyway. We create an offer. We call set remote description on the other side, set local description on the local side, create an answer, call set remote description, and set local description. And then all the ICE candidate exchange starts, which is wired up here. And then we just negotiate.
So up until here, we did nothing of what we wanted. We just created a peer connection that actually receives incoming audio. So we have something to work with.
Yes.
Okay.
And then we do a set interval call, which calls the function. We give it every 200 milliseconds in this case. How often you do this is up to you. And we're going to argue about that later. How often is good, the right amount. So what we do here is we get the audio receiver. In this case, we only have a single one, but you might have to iterate over all your peer connections or over all audio receivers on your single peer connection. And we check for support for the getSynchronization_sources method. And then we get the synchronization source.
Okay.
And if we get something from that, and we might not in some cases, because there's a 10-second timeout on it, we push the audio level to our array of levels. And then we make sure we only have a backlog of 10 audio levels, which we can do things like average on or whatever you want. And then we do update our display element. You can see that here on the right, it's just running through the numbers here.
Yep, and this is me speaking to you somehow, and the numbers don't make sense, but this is how you do it.
Yes.
Okay.
And we can, for example, toggle the mute button, and then we see, oh, no audio received on the remote end anymore.
Oh, it's not me speaking. It's actually you because it's locally.
Yes.
Okay.
Yes, and the audio doesn't go from my headphones to my microphone.
Yes. Yes. Okay. So that's how you do it. And now, where exactly do we want it that way?
Well, I mean, the question is really, how do you average this? Because getSynchronization_Source gives you an instantaneous audio level, and well, the audio level would have been 0 for some part of the last seconds, but not all of that.
You mean when I try to breathe between words? Or pause when I speak? Okay.
Yes. So you should do some kind of averaging over a time window. Okay,
so let's say I've got 20 people in my call, all of them with open mix, not that, not that common, but let's say that they all have open mix. And now I'm receiving 20 different audio channels incoming. If I do that very frequently, let's say every 20 milliseconds, that's 50 checks per incoming audio channel, which means 500 for 10 and 1,000 different checks in this callback if I'm doing 20 people.
Yes, and luckily this getSynchronization_Sources API is lightweight enough that it's possible, because doing it with getStats will explode in that case.
Okay, and then my thought is that I don't care about possible. I want to be optimal. And if I try to do that, then probably I should try to check less times, or to check only when, or to start checking frequently only when things change, or find some other heuristic to help me out running less of these callbacks instead of more of these callbacks.
Yes.
Okay. But I guess people here should be smart enough to figure that out on their own anyways.
It's a hard problem.
Okay. Thank you. And go check your audio levels. See you next month.
See you. Bye.